So in the second video for the Chapter 6 review, I want to get into now molecules. Now basically the math is identical to what we just saw in the first one dealing with atoms. It's just that now you got more atoms in the molecule, of course. Something we saw back at the end of Chapter 5 was something called formula mass. I may have called it molecular weight in the Chapter 5 video. Let's go ahead and just get it out of the way. It's something we're going to use. NO2, nitrogen dioxide. We have one nitrogen. We have two oxygens. And what we're doing here is we're just taking the number of each atom, and we're going to multiply it by the atomic weight that's on the periodic table. I'm going to leave the units out here just because I'm running out of room. So obviously that's 14.01. This one is 32. I add these two together and that gives me 46.01. And this is grams per mole. Now I know there's a bunch of different names. Again, I said a formula mass, atomic weight. Okay, molar mass is going to be the one that's going to be most commonly used because that's the one that we always use in calculations. This molar mass is the same concept as the molar mass for helium that we saw back in the previous video. If I go in a laboratory, if I weigh out 46.01 grams of this sample, I have 1 mole in front of me, and that 1 mole would represent an Avogadro's number of those molecules. So this mole concept is allowing me to transition between something I can measure in the laboratory, the mass, and then something that I can physically count, in this case the number of molecules. And we'll use this for our calculation. Let's do our calculation. Okay, so we want to go from grams to moles. Well, the molar mass is perfect for this. It has both units embedded within it. It's our conversion factor. It's a conversion factor you'll use all the time when you do this step in calculations. Start with what's given. Again, 3 sig figs. I got one step in my calculations. I need one of these set of parentheses. Which one will go on bottom? Well, it's the unit that I started with, the unit that I want to cancel out with. So I'm going to divide by the 46.01, 1 mole up top. And like I've said before, right, this is a template to keep track of what I'm multiplying by and what I'm dividing by. So in this case, I just need to divide by 46.01 in my calculator. Grams cancel out. And I am left with, again, to 3 significant figures, 0.0256. So some fraction of a mole. Now these zeros here are not significant. And what that means is that oftentimes you rewrite this. 1, 2, if I'm going down to the right, then my exponent for my scientific notation is going to be a negative value, -2 moles. So that's not uncommon to change a number. If you have zeros that are not significant, oftentimes you convert it to scientific notation to get rid of those zeros. Now in this example, we're starting with water, we're starting with grams, just like in the last problem, but we're not wanting to stop at moles. We actually want to go to molecules. So what we're going to do are these 2 steps. Now we should know that water has the formula H2O. That gives it a molar mass of 18.02 grams per mole. That's going to be used in my first step, and then Avogadro's number is going to be used there. And just let's write that out. Avogadro's number now is, right, it's 6.02 times 10 to the 23. In this case, it's a molecule, so we'll call it molecules, and that equals 1 mole. And again, there's that mole playing the role as the one in the middle. Start with grams, transition to moles, and finally over to the number of molecules. Let's do the setup. Again, start with what's given. Mass of our water. I have 2 steps in my calculations. That means I'm going to have 2 of these sets of parentheses. Take them one at a time. Molar mass here. So grams, I want to cancel out. 18.02 grams equals 1 mole. So it's 18.02 that's going to go on the bottom. So I'm going to divide by that number. Right, let's just start inking some of that in. Grams cancel out, so I'm going to divide by that. Next step, I'll start with moles for my next step. What's the relationship? What's the conversion factor? It's this one. This portion is going to go on the bottom. Okay? And then Avogadro's number is going to go on top. So I'm going to multiply by Avogadro's number. Again, moles cancel out, multiply there. And then rounding to 3 significant figures, I have and that's it. Let me do one more thing with molar masses, and that's a percent composition calculation. So acetic acid, molecular formula is given, and we want to know the percent of oxygen in this particular sample. And we see there's 2 oxygen atoms there. So the way this is going to work, if I want to know the percent of oxygen, what I need to know is I'll just use mass of the oxygen in the sample over the mass of the acetic acid times 100. Right? Classic percent calculation. How much of what we're interested in over the total amount of what's there. Now, mass is not given to me in this problem. Like in the empirical formula laboratory, mass was determined experimentally, and you could just plug and chug the 2 masses in to figure out the mass of the different atoms. When you're given this kind of problem, instead of mass, think of molar mass. Okay, so molar mass. Now, we're just going to pull from the periodic table to figure out these amounts. First off, let's do the molar mass of the acetic acid. We'll do that in blue here. There's our formula. Okay, so just like on all molar masses, count up the number of each atom. 4 hydrogens, 2 oxygens. So sometimes, the atoms are scattered about, but you just add them all together. And then you look at the periodic table. And again, just like before, I'm going to just drop the units here for convenience. Okay, multiply each one of those together. And again, please go to the hundredths position. And I'm going to add. So this mass is 60.06 grams per mole. Let's just go ahead and insert that. Okay, that's going to be the bottom number. That's the total molar mass of what's there. And I'll go ahead and put the mole. Grams per mole is going to cancel out completely. And then what is the mass of all of the oxygen atoms in my formula, in my compound? Well, it's right here. It's 32 times 100. And since I have 4 sig figs in both of my numbers here, I'm going to use 4 sig figs in my final answer. 53.28% for oxygen in the compound. All right, and you could determine the percentages of the other 2 as well, if you wanted to. In the next video for Chapter 6, we'll look at empirical and molecular formula calculations. Thanks.